A thriving koi pond is a breathtaking display of color and tranquility, yet the health of its magnificent inhabitants and the clarity of the water depend entirely on one critical component, a good filtration system. Koi are beautiful but messy, producing significant waste that, if left unchecked, quickly transforms crystal clear water into a toxic, murky green environment. Choosing the right filter is not just about removing debris, it is about establishing a balanced, complex ecosystem that handles both mechanical cleanup and essential biological detoxification. Whether you need a simple box filter or an advanced drum system, selecting the right setup is the cornerstone of maintaining a pristine backyard oasis and ensuring your vibrant koi thrive. The three essentials of koi pond filtration: mechanical, biological, and UV. A truly effective koi pond filtration system is not a single unit, but a three-stage powerhouse, each component dedicated to a different critical task: mechanical removal, biological detoxification, and algae clarification. This integrated approach is the secret to maintaining the pristine water quality necessary for koi health. The process begins with mechanical filtration, the system's vacuum cleaner. Its sole purpose is to physically separate and remove all solid debris, everything from leaves and uneaten food to the significant waste produced by the koi themselves. Water is pushed through coarse media, such as filter brushes, mats, or screens, which trap the sludge before it can decompose, turn the water murky, and overload the subsequent stages. Removing this solid waste prevents it from dissolving into toxic compounds, setting the stage for the next essential phase. Next is biological filtration, the heart of the pond's ecosystem. This stage handles the invisible threat, the toxic ammonia and nitrite produced by fish waste and decaying organic matter. The biological filter provides a massive, high-surface area habitat for colonies of beneficial bacteria to colonize. These bacteria conduct the critical nitrogen cycle, converting ammonia into nitrite and then converting the even more toxic nitrite into relatively harmless nitrate. Without robust biological filtration, the water would rapidly become poisonous regardless of how clean it looks. Finally, the UV ultraviolet clarifier delivers the finishing touch: water clarity. While mechanical and biological filters manage the visible debris and chemical balance, the UV unit specifically targets the free-floating, single-celled algae that cause green water. As water passes over a powerful UV lamp housed within a protective chamber, the ultraviolet light damages the algae's DNA, causing the cells to clump together. These larger, now dead clumps can then be efficiently captured and removed by the mechanical filter media, resulting in the crystal clear pea soup 3 water that allows for a perfect view of your vibrant koi. Sizing your filter, matching capacity to pond volume and fish load. Selecting the correct filter is the most critical decision for maintaining a healthy koi pond, and it must be driven by two primary factors: the absolute pond volume and the total fish load. The mistake many beginners make is buying a filter rated exactly for their pond's gallon capacity, which is almost always insufficient for koi. A good starting point is to follow a general rule. Always choose a filter system, including the UV clarifier, rated for at least double and ideally triple the actual volume of your pond. This necessary overcapacity accounts for optimistic manufacturer claims and ensures the system can handle the biological demands of a koi habitat. Koi, being large and active fish, produce a high level of metabolic waste, which directly translates to a heavy biological load on the filtration system. The fish load is more than just the number of fish. It encompasses their size, the frequency of feeding, and the water temperature, which affects their metabolism. A deeply stocked koi pond, particularly one where the fish are growing to their full adult size, requires significantly more filter capacity and surface area for beneficial bacteria colonization than a casual garden pond. A standard recommendation for proper koi health and minimal stress suggests allowing approximately 250 gallons of water per mature adult koi. If your stocking level is higher than this, you have a heavy fish load and must increase the filter's rating proportionally. For example, a 1,000-gallon pond with a moderate koi population should select a filter system rated for 2,000 to 3,000 gallons. In a scenario with a very heavy koi load, many large fish, or high feeding rates, it is wise to exceed this, as the penalty for undersizing a filter is chronic water quality issues and a compromised biological cycle. Oversizing your filter is the best safeguard against rapid water degradation, providing a buffer that allows the biological filter time to efficiently convert toxic ammonia and nitrites even during peak feeding or environmental stress. Types of filter systems: gravity-fed versus pump-fed. Selecting a filter system involves a fundamental choice between two configurations, gravity-fed or pump-fed. This decision significantly impacts the efficiency of waste removal and the overall maintenance of a koi pond, especially when managing a heavy fish load. The pump-fed system is the simpler and typically less expensive installation, making it popular for casual garden ponds. In this setup, the pump is submerged in the pond, pushing water through a plumbing line to the filter unit, and then clean water returns to the pond. The main advantage is its ease of installation, as the external filter can be situated above the water level. However, for a high-volume koi pond, this system has a notable drawback. The pump's impeller chops up large solid waste, such as fish feces and uneaten food, before it reaches the mechanical filter. This macerated debris is much finer and more difficult for the filter media to capture, leading to quicker filter clogging and less effective solid waste removal. Conversely, a gravity-fed system is widely regarded as the superior option for dedicated koi ponds. In this configuration, the pond water, driven by natural hydrostatic pressure and often collected via one or more bottom drains, flows directly into a filter unit that is set level or below the pond's waterline. The large, unsightly debris settles in the filter's settlement chamber or pre-filter, like a sieve or drum filter, before the water passes to the pump. The pump is installed after the mechanical filtration stage, where it pushes the pre-filtered water through the biological media and back into the pond. The primary advantage is that the solid waste remains intact until it reaches the filter, allowing for much more efficient mechanical removal. This reduces the burden on the biological media, ensures a more consistent flow rate, and significantly lowers maintenance and cleaning frequency, critical benefits for a koi pond with the heavy bioload and stringent water quality needs of mature fish. The critical role of biological filtration and media. While mechanical filtration handles the large visible debris, it is the biological filter that is perhaps the most crucial component of a successful koi pond system, as it addresses the invisible, toxic waste products that threaten the fish's health. This essential stage is dedicated to facilitating the nitrogen cycle, the natural process that recycles fish waste. Mature koi produce a significant amount of waste, primarily in the form of highly toxic ammonia. The biological filter media provides a vast, protected surface area where beneficial bacteria, often referred to as nitrifying bacteria, can colonize and thrive. Water is pushed through this media, exposing the bacteria to the waste. First, one strain of bacteria converts the deadly ammonia into a less toxic substance called nitrite. Subsequently, a second strain of bacteria converts the nitrite into relatively harmless nitrate. The resulting nitrate is then absorbed by pond plants or removed via partial water changes. The media's primary function is not to trap particles, but to maximize the living space for these microorganisms. Thus, modern media, like ceramic rings, bioballs, and specialized ribbon-like materials, are engineered for extremely high surface area, SA per volume. The system's design, where the large solid waste is removed by the pre-filter before the water reaches this stage, is a critical advantage. By ensuring the water is pre-filtered and nearly free of sludge, the biological media remains clean, preventing the bacteria colonies from being smothered, which is vital for maintaining a consistent and heavy bioload processing capacity. Without this robust and uninterrupted biological stage, the toxic buildup in the pond would quickly become lethal to the sensitive and valuable koi. In-depth look at mechanical pre-filtration and debris removal. The mechanical pre-filtration stage is the foundation of a successful koi pond system, serving as the essential first line of defense against solid organic waste. This stage's primary mission is the physical removal of large and small debris, such as fish waste, uneaten food, algae clumps, and environmental matter like leaves and silt before the water proceeds to the sensitive biological filter. By intercepting these solids, the mechanical filter ensures that the biological media remains clean, allowing nitrifying bacteria to thrive and efficiently process toxic compounds without being smothered by sludge. Historically, mechanical removal relied on gravity-fed systems like settlement chambers and vortex filters, which slow the water flow to allow heavy particles to sink to the bottom for manual flushing. While effective for coarse debris, modern koi keeping demands more sophisticated, fine micron filtration to polish the water. Advanced systems, such as sieves and the state-of-the-art rotary drum filter, RDF, represent a significant leap forward. The RDF, for example, is an intelligent, automated system that utilizes a fine mesh screen, often between 50 and 100 microns, to capture even the smallest suspended particles. When the water level inside the drum drops due to particle accumulation on the screen, a sensor triggers an automatic backwash cycle. The drum rotates, and high-pressure jets spray the captured debris into a waste tray. This self-cleaning mechanism ensures consistent, high-volume water flow and prevents clogging without manual intervention, which is vital for maintaining the system's overall processing capacity. This robust debris removal offers two critical benefits. First, it prevents the massive, rapid decomposition of organic matter that would otherwise consume the pond's dissolved oxygen, DO, which is lethal to koi. Second, by keeping the biological filter media pristine and the water highly oxygenated, it guarantees the uninterrupted and heavy bioload processing capacity required to keep the pond's water quality stable and non-lethal. Advanced filtration technology, drum and bead filters. While the rotary drum filter, RDF, is the unrivaled master of mechanical pre-filtration, an advanced koi pond system requires a sophisticated secondary stage to handle the immense biological load. This is where the bead filter technology becomes indispensable, often installed directly after the drum unit for a synergistic approach. Bead filters utilize a dense, packed bed of small plastic beads, which serve a critical dual function. Mechanically, the tiny gaps between the beads capture extremely fine particulate matter that may have bypassed the drum filter's mesh screen, effectively polishing the water to exceptional clarity. Biologically, the massive collective surface area of these beads provides an ideal habitat for colonies of beneficial bacteria, making the bead filter an incredibly high-efficiency biological processor, rapidly converting toxic ammonia and nitrite into harmless nitrate through the process of nitrification. Maintenance of this system is designed for maximum efficacy and minimal disruption. Unlike traditional biofilters that can clog and risk destroying the delicate bacterial biofilm during cleaning, bead filters employ a unique air-assisted backwash. This mechanism tumbles the beads to release trapped mechanical debris, which is then flushed away, while simultaneously minimizing shear stress on the biofilm itself. The ultimate benefit lies in the combined operation. The RDF ensures that the water entering the bead filter is nearly free of large organic solids, guaranteeing that the bead filter's biological media remains pristine and highly oxygenated for peak nitrification performance. This two-part advanced filtration system, heavy-duty mechanical pre-filtration followed by ultra-efficient biological processing, is the gold standard for maintaining the stable, non-lethal water quality required for champion-grade koi. Understanding UV sterilizers and clarifiers for algae control. Even the most advanced mechanical and biological filtration systems, such as the RDF and bead filter combination, can be challenged by the relentless growth of single-celled planktonic algae, which manifests as green water. To achieve true gin-clear water, ultraviolet UV treatment is the final, essential stage. The distinction between a UV clarifier and a UV sterilizer is primarily a matter of dose and flow rate. while a true UV sterilizer delivers a high enough dose of UVC light to kill harmful bacteria, viruses, and parasites, requiring a very slow flow. The units used on most koi ponds function primarily as UV clarifiers. A UV clarifier's moderate exposure time is perfectly calibrated to disrupt the DNA structure of single-celled algae, preventing them from reproducing. This exposure causes the microscopic algae cells to flocculate, or clump together, into particles large enough to be effectively trapped and removed by the mechanical filtration stages, such as the RDF or the bead filter. This physical removal is key. Unlike chemical algicides, UV treatment leaves no residue in the water and does not affect the pond's pH or the established beneficial bacterial biofilm within the biological filter. For this technology to be effective against a heavy algae load, particularly in a sun-exposed, nutrient-rich koi pond, correct sizing is paramount. A general guideline for robust greenwater eradication, clarification, is to utilize a unit providing at least 8 to 10 watts of UV power per 1,000 gallons of pond water. Undersizing a unit, or allowing the quart sleeve to build up scale, dramatically reduces the effective dose, rendering the system useless. When integrated after the heavy mechanical pre-filtration, like the RDF, the UV clarifier's bulb and quart sleeve remain cleaner, ensuring the maximum UV light is delivered to the water for crystal clear results, thereby completing the gold standard filtration triad. Choosing the right filter media for maximum efficiency. The cornerstone of a successful koi pond is the biological filter, and its efficiency hinges entirely on the chosen filter media. This media provides the substrate for the beneficial nitrifying bacteria, the established beneficial bacterial biofilm mentioned previously, that convert toxic ammonia and nitrite into harmless nitrate. To achieve maximum efficiency, the media must offer the largest possible protected surface area per unit volume. The two main philosophies center around moving bed and static bed media. For static beds, highly porous media like sintered glass, porous ceramics, and specialized products such as Biohome or Matrix excel. These media possess an intricate internal structure that offers a truly massive surface area, often dwarfing that of traditional plastic balls or foam, making them ideal for high bioload systems. This massive surface area supports a larger, more stable bacterial colony, leading to superior water purification. Conversely, for dynamic or moving bed filters, specialized media like K1, Coldness, or K+ media are the gold standard. These lightweight, wheel-shaped media are designed to be constantly agitated by air, which serves two critical functions. It maximizes oxygen transfer to the bacteria, speeding up the nitrification process, and it allows the media to gently self-clean. This self-cleaning action sloughs off older, less efficient bacteria and trapped sludge, maintaining a thin, young, and highly active biofilm. This prevents clogging and ensures consistent biological performance, a key advantage over static media that can accumulate detritus and require periodic manual cleaning. Ultimately, maximizing biological efficiency involves selecting a high surface area media that is appropriate for the filter housing, i.e., porous ceramics for showers or gravity-fed bays, and K1 for a moving bed reactor, and ensuring it receives adequate oxygen and consistent pre-filtration from mechanical stages like the RDF or bead filter. Maintenance and backwashing, keeping your filter effective. Sustained biological efficiency hinges not just on initial filter design, but on a rigorous and appropriate maintenance routine. For pressurized filters, such as a bead filter, the primary maintenance procedure is backwashing. This is a necessary periodic intervention, often triggered by a drop in flow rate or a specified rise in pressure on the gauge, which indicates the media is becoming clogged with fine solids. The backwashing process involves temporarily reversing the water flow and often using an integrated blower to aggressively agitate the media, sloughing off accumulated sludge and older, less efficient layers of biofilm. The contaminated water is then dumped to waste, and the process resets the filter's mechanical performance. Typically, backwashing is required every 1 to 2 weeks, depending on the pond's fish load and feeding regime. A key distinction must be drawn between this process and the maintenance of a moving bed reactor. While a bead filter's backwash is a violent, required interruption, the K1 media in a moving bed is designed for continuous, gentle self-cleaning through constant air agitation. This process perpetually maintains the media's thin, active biofilm, meaning the biological chamber itself rarely requires manual cleaning or an aggressive periodic backwash. This difference is a major advantage for maintaining a consistent, high-performing biological population. Crucially, all biological filter cleaning must prioritize the preservation of the beneficial bacteria. Whether backwashing a bead filter or manually rinsing a shower filter, only dechlorinated or pond water should be used, as tap water's chlorine will instantly destroy the established biofilm. Ultimately, the frequency and aggression of backwashing on the biological stages can be dramatically reduced by ensuring the pre-filtration stages are impeccably maintained. A rotary drum filter, RDF, or a sieve that is regularly cleaned or automatically flushed minimizes the solid waste reaching the biological media, drastically lowering the load and ensuring your high-efficiency biological filter remains effective with minimal intrusive maintenance. Comparison of top-rated koi pond filter systems. A comparative analysis of top-rated koi pond filter systems reveals a clear divergence in approach, primarily centered on how they handle mechanical separation and the subsequent impact on biological stability. The gold standard for mechanical pre-filtration is the rotary drum filter, RDF, or an automated sieve system, which utilizes a fine mesh screen, often 200 to 300 microns, to physically remove solid waste. The RDF's self-cleaning automatic backwash is performed with pond water, minimizing maintenance and, crucially, ensuring the least possible solid waste reaches the subsequent biological stages. This direct, automated removal of debris is critical for protecting the biological filter. In contrast, bead filters operate as a combined mechanical and biological system. While capable of both solids capture and nitrification, their mechanical efficiency is lower than an RDF. More significantly, the aggressive backwashing required to clear the retained solids poses a recurrent risk of disrupting or damaging the beneficial bacterial biofilm, directly conflicting with the priority of preserving the biological population. For purely biological power, the Baki shower, or trickle tower, stands out. These systems are celebrated for their exceptional biological filtration and superior oxygenation, making them highly effective at removing ammonia and nitrate. By utilizing media with a high surface area and a trickle flow, they inherently support the thin, active biofilm mentioned in the main context, meaning the biological media itself rarely requires intrusive cleaning. The best-performing pond systems often employ a synergistic approach. An RDF handles all mechanical pre-filtration, effectively taking the high solids load off the system, followed by a dedicated, low-maintenance biological stage like a Baki shower, guaranteeing minimal disturbance to the high-efficiency nitrifying bacteria. This separation of duties is the most reliable path to achieving clear water with minimal periodic maintenance. The most effective koi pond filtration strategy relies on the dedicated separation of mechanical and biological duties. The rotary drum filter, RDF, is the gold standard for mechanical pre-filtration, utilizing automatic backwash to efficiently remove solids and crucially protect subsequent stages. This is superior to combined systems like bead filters, which risk biological disruption due to aggressive cleaning. Pairing the RDF's high-efficiency pre-filtration with a dedicated biological system, such as the Baki shower, creates a powerful synergy. This combination guarantees minimal disturbance to the nitrifying bacteria, resulting in superior oxygenation, clear water, and the most reliable path to low-maintenance pond health.